Greetings. I'm Neeraj Guru. This is my presentation on C312 Optimization Techniques course project. Topic presented is implementation of simplex algorithm in Python. Professor. The project aims to decline towards academic uses rather than to be applied for a specific problem. The algorithm was implemented in Python using NumPy library. It is capable of solving most of the theoretical optimization problems, which can be solved using Simplex Method. The program takes the maximization type of optimization problem along with the objective function and constraints as inputs and produces appropriate result when they are passed in standard form. The table of attribute variables corresponding to each iteration of the algorithm are shown along with the optimal value and solution of the objective function corresponding to the constraints as output. Table of contents. As the PDF progresses further, these topics will be discussed. Introduction to Simplex algorithm. The Simplex algorithm, developed by George Danzig in 1947, is the first practical procedure used to solve the linear programming problem. The intuition behind the algorithm is to move from corner to corner in a feasible region of space in a systematic way along the edges. When the optimal solution is found, it stops. In simplex algorithm, the feasible region is the visual representation of the given constraints and restrictions. The objective would be to optimize an objective function. In this polygon, simplex method is an approach to solving linear programming models by hand using slack variables, tables, and pivot variables as a means towards finding the optimal solution of an optimization problem. An overlay of the steps that are to be followed when solving linear programming problems using simplex algorithm are shown on the left. The following are the steps to be followed when solving problems using simplex method. Step 1. Standard form. We need to convert the problem into a standard form. That is, the objective function should be of maximization type. The constraints must be in a less than or equal to inequality. All variables should be non-negative, that is, the restrictions. The inequality of the restriction should be greater than or equal to 7. Transform minimization from minimization linear program model to a maximization linear program model. We can consider the dual of the problem. Step 2. Introduction of slacks. We add slacks which are greater than or equal to 0 for each constraint in the standard form. This is to convert inequality constraints to equality constraints. The model is in standard form. Slack variables always have a +1 t-shirt. Go to step 3. Step 3. Creating table. The simplex table is used to perform row operations on the linear programming model as well as to check a solution for optimality. The table consists of the coefficient corresponding to the linear constraint variables and the coefficient of objective function. Step 4. Check optimality. The optimal solution of maximization linear programming model are the given values assigned to the variables in the objective function to give the largest zeta value, that is, the set value. These would exist on the corner points of the graph of the entire model. At optimal, all values in the last row must contain values less than or equal to 0. If a value is greater than 0, it means that the objective function does not reach its optimal value. Step 5. Identify pivot variables. Pivot variable is used in row operations and it will be converted into a unit value as the algorithm progresses further. To create a new table of finding optimal. The pivot variable can be identified by looking at the bottom of the table and indicate a column. Assuming that the solution is not optimal, pick the largest value in the bottom in the table. One of the values lying in the column of this value, the largest value at the bottom, will be pivot variable. This column is referred as column. find the indicator, we define the beta, that is the constants, values of linear constraints by their corresponding values from the pivot column. The intersection of the row with the smallest non-negative indicator in the pivot column will become the pivot variable containing the variable that is the pivot variable is referred as pivot row. Step 6. Creating a new table. The new table will be used to identify a new possible optimal solution. Now that the pivot variable has been identified in step 5, row operations can be performed to optimize the pivot variable and keeping the rest of the table equivalent. To optimize the pivot variable, it will need to be transformed into a unit value of 1. Transform the value. Multiply the pivot row by the reciprocal of the pivot value. After the unit value has been determined, the other values in the column containing the unit value will become 0. This is achieved by following this pseudo. The value in the new table is equal to negative of value in old table pivot column in corresponding row of the new value that is being found, multiplied with value in new table pivot row in the corresponding column of the value that is being found in the new table plus old value. This will be discussed in further detail using an example. Step 7. Identifying optimal values. Using new table, check for optimality. All values in the bottom are less than or equal to 0. Then the optimality has been reached. If not, we need to repeat steps 4, 5, 6 till we reach the optimal value. Once the table is proven optimal, the optimal values can be identified by distinguishing the basic and non-basic variables. Basic variable can be classified to have a single one value in its column and the rest of the values in the column be zeros. In the final table, if the variable is basic, the row that contains the one value corresponds to the beta value. The beta value will represent the optimal solution for a given variable. Variable does not meet this criteria. It is considered as basic. If a variable is not basic, it means that optimal solution of the variable is 0. Understanding simplex through an example. The following example is explained by breaking down the simplex method as mentioned in the above slides. Example. Let us consider the maximization of objective function. That is maximize z equal to 40x1 plus 30x2 subject to constraints x1 plus x2 less than or equal to 12, 2x1 plus x2 less than or equal to 60, and restrictions of x1 and x2 being positive real numbers. Step 1. Standard form. The given objective function and the constraints are in standard form, so we don't need to change them. Step 2. Introduction of slack variables. The slacks S1 and S2 are introduced as follows into the constraints and transform them as x1 plus x2 plus s1 equal to 12 and 2x1 plus x2 plus s1 equal to 16. Please note that s1 and s2 are greater than or equal to 0 here. Step 3. Creating the table. The initial table is created as follows. Table is shown and we can see that it contains coefficients of linear constraints and the objective function. Step 4. Checking optimality. Initial table in the last row, we start with coefficients of the optimization function. They are positive and hence optimality condition is not met with. Identifying pivot variables. Step 5. The pivot variable can be identified by looking at the bottom of table and the indicator. Pick the largest value in the bottom. Corresponding column is pivot column. Find the indicator by dividing beta values of linear constraints by their corresponding values from the pivot column containing the possible pivot variable. So what we do here is we create an indicator column. The values of the indicator column can be so the beta value divided by the corresponding x value. So for the first one, start variable s1, the beta value is 12 and we divide it with the corresponding value in the pivot column. That is the column containing the largest value in the last row. So column containing the largest value in the last row is first column. The largest value in the last row is 40. So the column containing this element is the column corresponding to x1 variable. So indicator can be found by dividing beta with the x1. So each value of beta column is divided with the corresponding value of x1 column. So 12 is divided with 1 in x1 column and 16 in row of beta is divided with 2 of row 2 in x1 column. Please note that as the method starts, we first fix the basic variables as the slack variables, and please note that the cost is the coefficient corresponding to the variables that are mentioned right after it. That is the coefficient of S1 and coefficient of S2 in the objective function is their cost. So in this whole table, the pivot variable will be 2. As we know that the pivot variable is the intersection of pivot column and pivot row. The pivot row is the row corresponding to the lowest non-negative value of the indicator. 16 by 2 is 8. That is less than or equal to 12. Hence the row containing 16 by 2 will be the pivot row. And the intersection of this with the x1, that is the pivot column, would be the pivot variable. We proceed further into step 6. Create a new table. To optimize the pivot variable, it will need to be transformed into a unit value. Transform the value, multiply the row containing the pivot variable by the reciprocal of the pivot value. In the example below, the pivot value is originally 2. So multiply the entire row by 1 by 2. And this makes our pivot variable into a unit. And all the elements in the pivot row are changed correspondingly. So we do this in order to perform row operations in the table. So we want all the elements that are in the row corresponding to the pivot column, all the elements in the column corresponding to the pivot column are to be 0, other than the pivot variable. We need to nullify the values in the pivot column. So this is achieved with the row operations, and we follow the algorithm that we previously discussed. After the unit value has been determined, the other values in the column containing the unit value become 0. This is achieved by following the pseudo code, which is mentioned before. Using this, we nullify the values of the pivot column other than the pivot variable or the unity that we achieved by manipulating. So this is the whole table which we had for making the pivot variable into a unity. So here the pivot variable is 2. And now the new table, observe that the pivot variable is made into a unity and the entire row has been changed as we multiply the entire row format. So let's understand this algorithm and how we apply this algorithm for each element of the table to achieve zeros in the pivot column. So we need to observe that before the entire new table is constructed, the only row that is present in the new table is the row, the second row, that is the row with the pivot variable, and the rows other than this row will be changed from the old table. So this how they are changed according to this algorithm. So consider this element, this value of the new table. So how we find value in first row of first column in the new table. Find the negative value in the old table pivot column corresponding to the row. So what will be this negative value of the old table pivot column corresponding will be -1. So the corresponding row of first row of first element is row 1, and the negative value in the old pivot column is negative of the value in the first row of pivot column. So that is negative of 1. That is multiplied with value negative new table pivot row in the corresponding column. So the new table corresponding column is first column, since we are finding the value of the new element in the first row, first column, the new table. So the value new table pivot row in the corresponding column, that is the first column, is 1. So negative of -1 to 1 plus the old table value, that is 1. So this will be 0. So this is row operation that we perform over the entire row to make the values corresponding to the pivot column 0. But we are dissecting the row operation in a level that it can be applied to each element of the table. So this whole algorithm is equivalent to row operation, which converts the value other than pivot variable pivot column 0. To this algorithm is that this makes it easier for a programmer to implement the algorithm, the row operation, for each and every element of a table that can be created in array forms in Python. So similarly, to find this element in the first row, second column in the new table, we take negative of value old table in our pivot column in the corresponding row. The corresponding row is first row. Negative value in the old table pivot column, the corresponding row. Negative value of the old table pivot column in the corresponding row is minus of this one that is being highlighted in blue. So this is multiplied with value in new table pivot column corresponding column. So here this is half. This with this half. This one with negative sign is being multiplied, and the old value is being added to the product. So that is half. Similarly, this element, the third element, the first row can be calculated in a similar fashion. Right. With this, the entire table can be constructed. Proceed further. Step 7, check optimality. And the table of the last one, the coefficient of x2, optimization function is positive. So here, the last row in the new table of constructor, the coefficient of x2, that is this entire row, the last value in this x2 row is positive. Since this is positive, the optimality is not yet reached. The optimality reached, we need all the elements in this row to be this or non-negative. Both coming. Step 8. We need to repeat the process till we reach optimality. So we need to identify new pivot variables. Identifying pivot variables. Pivot variable can be identified by the intersection of the smallest non-negative indicator. That is the new indicator that construct. And the largest positive value of the bottom. So construct this new indicator by first finding the pivot column first. So the last row, the largest value is 10, and the column corresponding to this 10 will be the pivot column. So the beta, when divided with the corresponding elements in the pivot column, the beta column elements divided with the corresponding elements in the pivot column produces the indicator. So when the pivot row is formed by taking the minimum value of the row that corresponds to the minimum value of the indicator. So here the row corresponding to the minimum value of the indicator is the first row, because 8 is less than 16. So whatever the row is 8, the minimum indicator, non-negative indicator contains, this will be the pivot row, and this will be the pivot column, the column corresponding to next row. Again, we create a new table after identifying the pivot variable. Make the pivot variable 1. Pivot variable is this variable previously, because this was the corresponding pivot column. First row was the pivot row. The second row, that is the row corresponding to next variable, was pivot column. With the second column, the column corresponding to next is pivot column. So make the pivot variable 1 by multiplying the row. In the table, the pivot value was half. So everything is multiplied. The entire row changes. The values that are indicated in red are the values that are about to be changed in the new table, creation of new table. So using the previous algorithm, we can find all the values that are corresponding to each value in the new table. So the new table is constructed to check for optimality. Check for optimality. Table, the last row all coefficients of optimization function are negative, and hence the optimality condition is negative. That is here in the new table that we constructed. All the coefficients are zeros and negative values. So we can see that we fetch the optimality. After After this, we move to the identification of optimal values. We identify the basic and non-basic variables from the table as basic variables x2 and x1, non-basic variables as well as x2. So the basic variables are the variables that have single unit value in their corresponding column. So column corresponding to x1 variable has single one in the row 2, and the column corresponding to x2 variable has a single one that is in the row 1. Variable x1 is found in second row. This shows that the optimal x1 value is found in the second row of beta values, which is 4. So optimal value of x1 is 4. So 1 is in second row. Beta value in second row corresponds to value of x1. Similarly, since 1 is in row 1, x2, optimal value is the beta value that is in the first row. Variable x2 has 1 in the first row, and the optimal value is 8 from the beta column. The beta variable has -400 in the last row. This shows that the maximum value will be negative of -400, that is 400. So whatever the optimal value that we achieve in this table, we need to multiply it with the negative sign to attain the actual optimal value. Hope the explanation is clear for simplex algorithm and actually the applications of simplex algorithm. Simplex algorithm is optimal in physics, complex equations, economics, engineering, and computer science. There are a few P's of the simplex algorithm. Linear programming. The simplex method is frequently used to solve problems in linear programming that call for optimization of the linear objective function under linear constraints. It can also be used in resource allocation. Simplex method allows for the efficient and economic distribution of resources like labor, capital, and raw materials in a way that maximizes efficiency and minimizes costs. It can also be production planning. Simplex can be used to optimize production rates and reduce costs, plan production schedules in the manufacturing industry. Can be also implemented in supply chain management. Simplex method can be used to optimize supply chain management by finding the most efficient way to transport goods from suppliers to customers. Financial planning. The simplex method can be used in financial planning to optimize investment portfolios by maximizing returns and minimizing risk. Traffic engineering. The simplex method can be used in traffic engineering to optimize traffic flow by finding the shortest routes between 2 points, minimizing congestion and travel time. Network analysis. The simplex method can be used in network analysis to optimize the flow of resources through a network, such as telecommunications or transportation. Conclusion. The simplex method is an approach for determining the optimal value of linear programming by hand. The method uses an optimization to satisfy the given constraints and values maximum zeta value. To use the simplex method, a given linear programming which the beam stand for, where slack variables can be then introduced. Using the table of pivot variables and optimal solutions can be used. Implementation of simplex in Python. To implement the explained simplex algorithm, we acquire NumPy library. So the algorithm is implemented for problems that are of maximization types, and the inputs must be in stack form. Most of the code is explained in the comments in the code block itself. So here's the basic list of velocity that we used in the slides. See the following steps. This is the reference that I used to take the slides. Hope I link it in the description. Check it out. If you like. We're discussing algorithm that is being implemented Python. Initial table when no operation is being performed. The initial table has the identity matrix of a dimension corresponding to the number of slack variables that we introduce. With the coefficients as a matrix on the left side of it. C is the coefficients of objective function, the coefficients of variables in the objective function. We add zeros this matrix on the left side because the coefficients of slack variables are zero in the objective function. Create a table of using vstack function of number. Internally we have stack and we are making an array of one dimension into two dimensions. That is the beta values are being converted into two dimensional arrays and transfers of them are being concatenated with the A matrix. Once you try to pen this down, you can understand the algorithm, what actually is happening here. Okay, we create the indices for the basic variables. This part, this block of the code is used to check the optimality condition. Go to the entire description. Most of the code is being explained in comments. So let's go. What is on this code? Shape the example that is implemented in slides is run. That is produced here can be verified through the example in the slides. So that's the problem, which is passed as arrays. So thank you for watching the video. Learn something from this.